This video is about graphing radicals and cubes, and we've actually graphed them once before at the beginning of the school year. Now we're just going to do more with them. So if you remember, we came up with certain basic points that we did for the parent function. So let's just try and plug in some points. If I plug in 0, square root of 0 is 0. If I plug in 1, oops, gotta write that down. If I plug in 1, square root of 1 is 1, so I can plot the point 1, 1. If I plug in negative 1, well, I can't take the square root of a negative number, so that's not going to work. I can plug in 2, but the square root of 2 is a decimal. Square root of 3 is a decimal, so I'm going to go to the square root of 4, which is just 2, so I'm going to plot the point 4, 2. Square root of 5 is a decimal, 6 is a decimal, 7, 8 are decimals, but the square root of 9 is 3, so the fourth point that I'm going to plot is 9, 3. So my graph looks like that. And every time that I have a radical, it's going to look like that. I'm going to follow the same pattern. So from my starting point, I'm going to go over 1 and up 1, over 4 up 2, over 9 up 3. Now my domain, the domain is the set of x values, and I read it from left to right. So going from left to right, there's nothing until I get to 0. 0 is included, so I have a bracket, and it keeps going to the right, so it goes to infinity. The range, I read from the bottom up, so there's nothing down below here, but it's starting at 0 at the y-axis, and then it continues to slowly rise up, and so it goes to infinity. Now, increasing and decreasing is whether if you're on a roller coaster it's going up or down. Well, this one, if I get on the left and I'm slowly moving along, it's going to be constantly moving up. Okay? It's never going to be moving down. So there is no decreasing. And the increasing interval, well, it starts increasing. We read it off the x. It starts increasing at 0 and goes all the way to infinity. Now, on the domain and range, I put brackets because those are talking about points that are included. The reason I put parentheses on the increasing is because at 0 the graph is neither going up nor down, and so this is just where it starts the trend of going up. So that's why we do a parentheses, not a bracket, and it'll always be that way on increasing and decreasing. All right, let's take a look at the cube. On the cube, I can plug in 0. 0 squared is 0, so I have this point. I can plug in positive 1. 1 cubed means 1 times 1 times 1, which is 1, so I get 1, 1. But unlike my radical, I can't plug in negative points. So if I plug in negative 1 cubed is negative 1 times negative 1 times negative 1, and we have an odd number of negatives. I have a negative answer, so I get negative 1. Well, so far that doesn't look like much, so let's try plugging in 2. 2 cubed is 8, so I'm going to go over 2 and up 8. And I can plug in negative 2 cubed, and I get negative 8. And so my graph looks like this. Every time I have a cube, starting at my starting point in the center, I'll go left and right 1, and then up and down 1, and then left and right 2, and up and down 8. My domain is from left to right, and all the x values are available to me, so it goes from negative infinity to infinity. The range, all the y values up and down are available, so it goes from negative infinity to infinity. This graph, as I'm getting on and writing it from left to right as if it was a roller coaster, is constantly going up. So it's never decreasing, and it's always increasing. Okay. When we do the cubes, the domain and range will always be negative infinity to infinity, and then it's either going to be increasing or decreasing. It can't be both. It's one or the other, and the one that it is negative infinity to infinity. The other is none. All right, now let's take those parent functions and move them a little bit. Well, anytime we have a number that's under the radical or in the parentheses, it shifts the graph left and right, and when it's left and right, it's the opposite of what you think it is. So minus 2 would actually be right 2. So my starting point is right 2. Now that I know from the center, and now that I know my starting point, I'm going to use the pattern of a radical, and the pattern of a radical is going to be over 1 from the starting point up 1, and from the starting point over 4 and up 2, and from the starting point over 9 and up 3, which would be slightly off my graph, but we can make that work. The domain is the set of x values. So I read it from left to right, and I have nothing until I get to 2. So my domain is 2 to infinity. Okay? The range is my y values, and I read it from the bottom up, and I've got nothing until I get to 0 on the y-axis. So it goes from 0 to infinity. This graph, as I move from left to right, is always going up, so it's always increasing. And when I read the increasing and decreasing intervals, I read them off the x-axis. So it started increasing at 2 and goes to infinity. It never decreases. With all of our graphs today, they're either going to be increasing or decreasing. They're not going to be both. All right, let's look at number 2. On number 2, what's in the parentheses shifts it left and right, and it's the opposite of what we think. So this one is going to be left 1. Okay? The number outside of the parentheses shifts the graph up and down, and when it's up and down, it's exactly what you think. So this one's going to be up 2. So my starting point is going to be over 1 and up 2. And now I'm going to use my pattern. The pattern says I'm going to go over 1 and up and down 1. From my starting point, and from my starting point I'm going to go over 2 and up and down 8. And there is the graph of my cube. Now remember, graphs and cubes, the domain and range is always negative infinity to infinity. In this graph, as I go from left to right, it's always going up, so the decreasing is none, and the increasing is negative infinity to infinity. All right, let's take a look at number 5. So the positive 3 in the radical tells me that I'm going to go left 3. The negative 4 says that I'm going to go down 4. So my starting point is left 3 and down 4, and now I'm going to use the pattern for a radical. The pattern for a radical says starting at my starting point, I'm going to go over 1 and up 1, over 4 and up 2, and over 9 and up 3, and there is my graph. The domain is my x values. So it starts at negative 3 because I read it from left to right, and it keeps on going to the right, so it goes to infinity. The range I read on the y-axis, so it starts at negative 4 and keeps going up to positive infinity. If I'm looking at this graph, it is always going up, so my decreasing is none. The increasing, when I read the increasing, I read it off the x-axis. So it starts going up here at negative 3 to infinity. And remember, increasing and decreasing is always in parentheses because at negative 3, it's neither up nor down. Okay, let's look at number 6. The negative 2 tells me that I'm going to go right 2. And the positive 3 tells me that I'm going to go up 3. So starting right 2 and up 3, that is my starting point. From my starting point, I'm going to use the pattern. My pattern says that I'm going to go over 1 and up 1, over 4 and up 2, over 9 and up 3. But because of this negative, instead of going up, I now have to go down. So I'm going to go over 1 and down 1, over 4 and down 2, and then over 9 and down 3, so that my graph looks like this. Oops, got an arrow pointing. So the domain is the x values. So it's where it starts. Well, it starts at 2, and it continues to the right, so it goes 2 to infinity. Now the range, remember, you read from bottom up. Well, this is going to keep going down, so I'm going to have values down here. So where it starts way down at the bottom, that actually is at negative infinity. And it goes all the way up to positive 3, and it stops at 3. Negative infinity can never be on the right of your interval. Okay, this graph, as I go from left to right, it's going down, so it's never increasing, it's only decreasing. And when I read the decreasing interval, I read it off of the x-axis, which is at 2, so it goes 2 to infinity, because when I'm talking about increasing and decreasing, I'm reading it left to right off the graph. Okay, number 7. Number 7, the positive 1 tells me that I'm going to go left 1, and the plus 2 says up 2. So at my point, I'm left 1 and up 2, and now I'm going to use my pattern for the cube. And the pattern from the cube says that I'm going to go over 1 and up and down 1 from the starting point, and from the starting point over 2 and up and down 8. And there is my graph. Now remember, this part's easy. On a cube, the domain and range is always negative infinity to infinity. This graph is always going up from left to right, so it's never decreasing. So it's increasing from negative infinity to infinity. Number 8, the negative 3 inside tells me that I'm going to go right 3, and the plus 2 says that I'm going to go up 2. So my starting point is right 3 and up 2, and then I'm going to use my pattern. However, with this negative, it's going to be the opposite. Normally I go right 1 and up 1, so I'm going to have to go right 1 and down 1, and right 2 and down 8. And normally I would go left 1 and down 1, so I have to go left 1 and up 1, and left 2 and up 8. So my graph looks like this. The domain is still going to be negative infinity to infinity, and so is the range. But this graph from left to right, it's going down. So it's going to have no increasing interval, but it's going to be decreasing from negative infinity to infinity. Okay, to save a little time on the video, I'm just going to do 2 from the back. Let's start with number 9. Number 9, the negative 4 tells me that I'm going to go right 4, and the negative 3 tells me that I'm going to go down 3. So I'm going to go right 4 and down 3. Now normally, for a square root, I'd go over 1 and up 1, over 4 and up 2, over 9 and up 3. But there's a 2 in front of it, and the 2 changes the up and down. So normally I'd go up 1, or I'd go over 1 and up 1, but I have to double my up, so I'm going to go up 2. And normally I'd go up 4. 1, 2, 3, 4. There we go. 4 and up 2, but I got to double that, so I'm going to go up 4, because 2 times 2 is 4. Okay? Now, the last point doesn't fit on my graph, but if it did, I'd go over 9, and normally I'd go up 3, but I got to double it, so I'd go up 6, so it would be somewhere out here. Okay, the domain. The domain is your x values, so we're going to read it off of here. So the domain, it starts at 4, and it keeps going to the right to infinity. The range, we read it from the bottom to top, so nothing, 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 until we get to negative 3, so it goes negative 3 to infinity. As I go from left to right, this one is going up, so it's never decreasing, and it's increasing when we read the increasing off of the x-axis. So it starts increasing at 4, and as I go to the right, it continues to increase. Okay, let's skip down and do number 11. But on number 11, I'm going to change this to a positive 1/2. Okay, so to get my starting point, I have to go right 3 and down 1. Okay, so right 3 and down 1 is my starting point. Now normally I'd go over 1 and up and down 1, and over 2 and up and down 8. But this half in front of it controls the up and down. So I'm going to go right 1, but instead of going up 1, I'm going to go up a half of 1, and then I'm going to go left and down a half, because a half is half of 1. And then normally I'd go over 2 and up 8, but I'm going to go over 2 and up 1, 2, 3, 4, because 4 is half of 8. And then I'd go left 2, but instead of going down 8, I'd go down 1, 2, 3, 4, because 4 is half of 8. And there's my graph. For a cube, the domain and range is always negative infinity to infinity. This one, as I go from left to right, is always going up, so there's no decreasing, and it's increasing from negative infinity to infinity.